Hello everyone. I'm going to introduce you our work, Reconstructing Event Regions for Event Extraction via Graph Attention Networks. My name is Patron and I'm the first author of this paper. Our work works on document-level event extraction task. So what is document-level event extraction? Well, basically, we extract event information from document level text instead of sentence level. Here is an example. We are given a document with several sentences and an event template with predefined event rows. We need to extract noun phrases such as terrorists and those names as role fillers in the template. This is pretty much the definition of document level event extraction. Previous work tried to solve this task by decomposing the document level text into sentence level and extract those role fillers from sentences one after another. But there is a crucial problem for such approaches that they may identify a lot of noises, like here, house, father. They are both false candidates. So we want to improve such a task by filtering such noises. How do we do it? Well, we find interesting phenomena that the document level event information try to concentrate in some regions, and we call them event regions. Uh, that means a document usually mentions a target event multiple times, and each time it uses multiple sentences to describe it. We call those multiple sentences as event region. Like here, we have two regions because the document mentioned a terrorism event twice. And the first time it uses 3 sentences, and the second time it uses 2 sentences. We are trying to use graph neural network to model such global document level information and trying to filter such noise in those candidates. That's our idea. So here is our overall architecture. Basically, we have 3 steps. The first step is the same as previous work. We use sentence level event extractor to extract those candidates. Like here, we use SEE to extract 8 candidates from a document. And the second step is to use graph to model the event regions. Here we define 2 types of relations and we use 3 edges to connect them. For the first type of relation, we call it within region affinity, and we have 2 types of edge for them. One is strong and another is weak. The strong one will connect those candidates within the same sentence. Like here we connect candidate 1 with candidate 2. And the weak one, we will connect those candidates that are in adjacent sentences. Like we connect candidate 1 with candidate 3 and also candidate 2 with candidate 3. The reason we do this is that we hypothesize that those candidates within the same sentence or adjacent sentence tend to be in the same region of a same event region. We want to capture such information. And But the second one is that we also use cross-regional convergence edge to connect those exactly the same candidate, but they are not in the same sentence or in adjacent sentence. Like here, we connect candidate 2 with candidate 7. We want there is information flow between those regions. Mm, After that, we uh, uh, our third step is that we use a JT layer to learn a new representation of these candidates, and then we use a classifier to classify them as either positive or negative, and we remove those negative to filter the whole all the candidates. Here I want to mention that in the third step, we use a technique called edge enriched JT. That means we turn each edge into a new node, and we want to utilize the features of this edge. Our experiment results show that this performs better. Here are our experiment results. We evaluate our method on two datasets. One is English version public Mark IV dataset. Another one is a Chinese version dataset constructed by ourselves. We call it Chinese financial event extraction data. Mm, for the mark data, we can see that our system EJT performs best across all the baselines, and we improved 4 points from uh, previous based model uh, in FE score. And also, I want to mention that our performance mostly comes from the better precision. We can see we improve the precision by 7 points. This makes sense because we have a filtering architecture to do that. We will have better precision. Mm, for the Chinese version dataset, our model also performs best across all the three type of event types, and we can see that uh, uh, here is a difference that we do not improve that much precision from previous based model from Yang. This is because this dataset is very special. The Those documents are from company announcements, and they have a property that they want. They usually mention the target event in just one sentence. So Yang's method will perform very high precision because they just utilize the main sentence to aggregate the information. But anyway, our model also performs the best across all the baseline. We also do some analysis for our method. First, we evaluate the how our model reconstruct those event regions. Like here, we can see in the mark dataset in the golden standard, the in the document we have an average of 1.76 regions. But after the sentence level event extractor, this distribution is broken. But after our model EAGT, we can reconstruct those numbers back to normal. And the same thing also happens to our Chinese dataset. Mm, Besides, we also find that the more edges or the more relations we utilize in our model, the better the performance on both of the datasets. Uh, so that's the analysis. That's pretty much everything about our work. Thank you very much. If you have any question, just contact me.